Okay, we've already introduced this concept of estimation, but let's just go over it a little bit again. What we're trying to do here is take a sample statistic, in this case X bar, and make an inference about the population parameter, in this case the mean. That's what inferential statistics is all about. What we're trying to do with estimation is determine the approximate value of a population parameter on the basis of a sample statistic. As we've already discussed, we don't use point estimators, we're going to use interval estimators. We're going to use a high and a low. We refer to the low as the LCL, or lower confidence limit. We refer to the high as the UCL, or the upper confidence limit. The reason we don't use a point estimator is because there's virtually 0% chance it's going to be right. An interval estimator, we can bound. And when we bound it, we can say, hey, there's 90% certainty, or the confidence level is in this range, or 95, or 99, okay? Some qualities of estimators, and I didn't really talk about this when we talked about mean, but I want to talk about these now. Some qualities that we want of estimators. The first one is this. We want any estimator we use to be unbiased, okay? And what that means, that makes sense. We don't want things to be biased. But what unbiased means is if its expected value, whatever the estimator we're using, its expected value is the same as the value of the parameter. Okay? Remember, expected value is if I sample an infinite amount, I keep doing, I keep rolling that die forever and ever and ever. I'm going to 1/6 of the time I'm going to get 1, 1/6 of the time I'm going to get 2. So that's what it's saying. Whatever estimator we use, it should be unbiased in that if I do it an infinite amount of times, I sample an infinite amount, it's going to equal that population parameter. The second thing is, it should be consistent. Okay? Consistent has to do with the sample size. If I sample more, we should be able to reduce the sampling error. And that we saw that is true when we talked about X bar and the population mean, right? X bar and mu, the more I sample, hey, the tighter I get, the less error I have. Don't worry about relatively efficient. I don't believe that doesn't apply to us. Okay. So we understand all that. So let's talk then about estimating a population proportion. And this is brand new. Okay. So we've already done this. We've already taken X bar, the sample mean, to make an inference about mu, the population mean. But as you guys know, the whole world of data isn't always interval. Okay. And when we don't have interval data, we can't calculate out means. When we have interval data, great. We can add things together, divide by how many there are. We have a measure of central location. But oftentimes we have nominal or ordinal data. When we have nominal or ordinal data and we want to describe something, what's the measure that we've been using called? What measure have we been using? What measure have we been using? If I want to describe the number or the makeup of this class major-wise, or gender-wise, or student-athlete-wise, or views on the presidential election. What measure would I use? Not mean, but what? Come on.
Frequency.
Huh?
Frequency.
Frequency, which leads to what, Alex? Leads to percentage or a proportion. Okay. So P is, and you guys saw this when we did the sampling distribution, P stands for the population proportion, okay? P stands for the population proportion. What do you think is a very good, unbiased, consistent estimator of the population proportion? Crazily enough, what? Lindsay? Z? Well, we're going to use Z. But remember, the sample mean was an unbiased, consistent estimator, that's X bar, of the population mean mu. What do you think is an unbiased, consistent estimator of the population proportion P? The sample proportion, right? Makes sense, right? That's what we're doing here. So we're going to use P hat, the sample proportion, to make an inference about P, the population proportion. And how does P hat, how do we derive P hat? Let's say I'm trying to figure out the percentage of people that woke up before 9 a.m. at St. Francis University, okay? And I use you guys as a sample. and there's 30 of you in here, and based on that, 18 of you told me that you woke up before 9 a.m. 18 out of 30. What is my p hat then? What is my p hat? Sarah? 30 is my n, right? That's my sample size. So 18 is my frequency. We call that x. The number of successes I get in that sample.
18 over 30.
So very good. My p hat is 18 over 30, which in stats world is x over n, or 60%, right? That the number of successes out the number you sample. So now you understand we're going to use p hat, the sample proportion, to make an inference about p, the population proportion. And I'm going to breeze through these slides because this talks about how it's derived, all those good things. But I think we are at a point where all we need at this point is the formula. Because we understand what estimation is, we understand what p hat is, we understand what the population proportion p is. All we need is the formula, and we need to learn how to apply the formula. So here it is. It says, the equation says that with repeated sampling for this population, the proportion of values for which the interval is equal to 1 minus alpha is the confidence level. So here's the formula. P hat, if we want to use p hat to make an inference about p, the formula we want is p hat plus minus. Why do you think we have plus minus there? What's that? It's going to give us a range. Okay, very good. And I'm sorry, this is the formula I want on this page. P hat plus or minus z sub alpha divided by 2. That's going to relate directly to what? As it did before. My confidence level times the square root of p hat times 1 minus p hat divided by n. A couple things I want you to note about this, just like when we talked about the population mean. If I increase the sample size n, what's going to happen to this value under the root symbol? It's going to get smaller, right? And if it gets smaller and I'm multiplying something smaller, what's going to happen to my confidence interval? I sample more, Brandon, what's going to happen to my confidence interval? It's going to get smaller, more precise. The other thing I want you to note is z sub alpha divided by 2, right here, the confidence level, same damn thing. If I increase that, if I want to be more confident, that number, if we're 95%, we're going to go to 99%. It's going to go from 1.96 to 2.575. What's that going to do? It's going to expand my interval, right? All right, so let's do a sample. Okay, and I'm just going to make up. I'm going to make up an example.
Are we ever going to have to solve the like the z alpha over 2? Are we ever going to, or are we just going to be getting it on this level?
I'm going to give you the table. There's a table in your book that gives you that. Okay?
Right, I understand that, but like, are we ever going to have to like figure out what the confidence level is as like the variable?
No.
Okay.
No. You'll just say a 90% confidence, 1.645.
Okay.
95%, 1.96. And I'll give you the table, but you're going to do these enough that you're just going to remember those. Okay? They're like special values. Okay. So let's say this. I'm going to make up an example. What is there something about St. Francis students we'd love to know? Anything? What would you like to know about St. Francis students? Has to be a proportion. Give me something, Brandon. You're a creative man. Come on. Percentage that what? Proportion of students that what? Logan, you look like you have an idea.
Women, 2 guys.
Okay. So we went to proportion of St. Francis University students that are female. Okay. I think it's around 67%. But, so it's known, so I probably wouldn't do it for that. But I could. Give me something you'd want to know. That's not known, that we can't go and look up in the admissions office.
GPA is over 3.7.
Nah, we won't look it up. It's a system. What else?
How many students are international?
Nah, we can look that up in the admissions office. Easy.
Percentage who like drink every night or something
Okay. Uh,
Every night.
and actually, they do that survey, don't they?
Yeah.
You guys ever been trapped in a class and they come in, the drug and alcohol people come in and they say, you know, and there's all kind of questions about, you know, usage. Ever been in that class, Kylie?
Yeah.
And then they publish it, and do they, and I know this for a fact, do they talk to every St. Francis student? No, they survey about 400, okay? Which is a pretty good sample size. And then they publish those results, and they trend it, and they see where it is. And what do you think they do with those results? Not, they say like, okay, 2% of St. Francis University students use marijuana regularly. Maybe, I don't know what it is. What do you think they compare that to? Yeah, it's a national survey. That survey is given nationally, and they say, hey, are we above the line, or do we have a problem, or is it just, hey, we got 20-year-olds here, that's what happens, you know? Or are we way above? Is there more binge drinking here than average? You know, whatever it might be. So, okay, so that's the issue. Let's say that is the issue. And I sample, and I say, you know, what percentage of the campus community, let's say as a question, what's a binge drink? How many is considered binge drinking? You know, 4? It's pretty low. I mean, not that 4 is. I'm saying anytime you probably it is. It's pretty low. Like what the health experts say is binge drinking. It's like 4 or 5. Okay. So let's say we ask St. Francis University students if on a given week, they've had 4 or more alcoholic beverages in a sitting. And let's say, well, let's make it easy. Let's say we sample 120. And let's say from that, I'm just going to throw out a number. Let's say 45 said that they have had more than 4 alcoholic beverages in a sitting, okay, during that week. All right. Couple things I want to know. I want you to estimate with 95% confidence, okay, the percentage of SFU students that have binge drinked in the last week. Binge drank? How do you say that? Binge drunk?
They say it's 4 drinks at least twice a month.
I thought it was like 4 drinks. Yeah. Something like that. Okay, so percentage of SFU students that binge drink? And then I want you to estimate the number of SFU students that binge drink. So do you understand? I'm asking for 2 things. I'm asking for a percentage, and then the number of you that binge drink. Figure it out.